Hello everyone, welcome back to another video on machine learning, and in this particular video we'll be focusing on anomaly detection. So we'll be focusing on isolation forest, one class SVM and kernel density. I am your AIML consultant Shaunak, and let's begin. So the dataset that we are going to use, I have got this dataset from Kaggle. So it tells the number of Twitter mentions for these companies. We have a column called as timestamp, on which date and time is mentioned, and the number of tweets for Apple, Amazon, Salesforce, CVS. There are several companies, and for this particular demonstration we are going to focus on Apple. For practice purpose you can of course go for other companies as well, Amazon, Salesforce, but for demonstration purpose I'll be focusing on Apple. The number of times Apple is mentioned in tweets for this particular date and time. So let us quickly proceed on importing the libraries. For data wrangling we will be using pandas, so import pandas as pd. For complex numeric calculations, basically we are going to make use of only one such item, quantile. So let me import that from numpy import quantile. So we are going to use quantile when we are dealing with kernel density. So while defining the threshold in kernel density we are going to make use of quantile. Then let us import the machine learning algorithms from sklearn.ensemble import isolation forest. From sklearn.neighbors import kernel density. From sklearn.neighbors import kernel density and svm. From sklearn.svm import one class svm. So these are the algorithms that we will be using. Also one more thing, let me quickly increase the zoom so it will be easier for you to read. Sorry. And for graphical representation we will be also be plotting the graph. So for that we will be making use of plotly. Import plotly.express as px. We will be plotting scatter plots. So let me execute this code block. Okay, it is executed. I am going to ignore the warnings. That's why these two lines of code 15 and 16, import warnings, warnings.filter warnings, ignore. So we will be ignoring the warnings. I have this data set kept on my local machine at this particular relative path. So dataset path, that is the variable containing the path, and the company will be focusing on is Apple. So why I have not hard coded Apple and just kept it in this variable is, down the line if you want to practice or check for other companies like Amazon, CVS, Salesforce, you can just replace this Apple by Amazon, CVS or Salesforce. So let us read the data into a data frame. So raw df, this will be the name of our data frame. So pd.read csv, and here we will pass this dataset path. And the columns that we are interested in is this timestamp column and Apple. So timestamp, and instead of Apple I'll be using this variable company. Upon execution, raw df head, it is appearing like this, timestamp Apple. So here we are getting the timestamp and here we are getting the number of Twitter mentions for the company. Now let us quickly process this data frame to convert this timestamp to we will be converting that to, right now it is date and hour. So we also have different values for different minutes and seconds. So instead of that we will be converting this to only date and hour, and we will be aggregating the number of Twitter mentions on hourly basis. So let us first check the data type you do that using info. Okay, so timestamp data type is object. There are in total 15,902 observations, and apple number of tweets is in integer format, which is required as per our requirement. If it is not as per our requirement, we will have to change the data type. In our case, we only have to change the data type of this timestamp, and we will convert it to date time. So let us first convert the date time to date time and hour for grouping. So we will remove this 40 minutes and seconds, and we will replace it with 00, because we want to group the data frame on hourly basis. So raw df equal to raw df dot before group by, let me quickly convert this timestamp to only date time and hour. I will use map and lambda, la mbda lambda time, and I'll convert it to f string. So this time I will split it on the first colon, so I'll be only considering this part, and the remaining part I'll be replacing with 00. So time dot split, and not double inverted, because double inverted is already being used in this f string. So I'll use single inverted, and I will split based upon the colon, and I'm going to take only the first part of it, hence 0, and then followed by outside 0000. Now that is done, and this is how our data frame now looks like. Date and only the hour, minutes and seconds I have converted it to 0. And now let us convert this timestamp to date time. So raw df timestamp, and how to convert it? It is pd dot to date time, and then pass that particular column. And now if you check the data type, raw df dot info, the data type which was earlier appearing as object, it is now appearing as date time. So as per the requirement. Now check for missing values. If there are any missing values, raw df dot is na dot sum, this will tell us if there are any missing values in our columns. So since it is 0, so there are no missing values, so we do not have to deal with missing values. I'll just remove these code blocks because there aren't any missing values, so we don't have to drop or impute missing values. Okay, now let us group and aggregate tweet mentions by hour. So raw df equal to raw df dot group by, we are going to group by timestamp, because here if you see, for this particular date 26 February 2015 at 21 hours we have 4 observations. So instead of 4 observations, we will group them together into only one observation, and we will aggregate, add all these number of Twitter mentions for this particular hour. So group by timestamp, and as index will be false, because I do not want to convert this timestamp into index, so I will keep it as index as false. If I keep it as true, or if I do not mention it, this timestamp column will get converted to index. Instead of 0, 1, 2, 3, you will get timestamp over there. And then I will do the sum, and this is how our raw df will appear. So instead of 4 different observations, we have only one observation for this particular date and time, and it has aggregated the number of Twitter mentions to 457 for this particular example, 26 February 9 o'clock, that is 21 hours 457. Earlier it was 104, 199, 154. So we have just aggregated that, grouped it. I'll create a helper function. So to plot the graph, what I will do is take input parameter as name of the method. So we are going to take a look at three methods here, which is isolation forest, oneclasssvm, and kernel density. So this method I am going to make use of to put the title of our graph. So first will be the name of the method, then the data frame based upon which we are going to plot the scatter plot, then x column, name of the x column, name of the y column, and then the name of the anomaly column. By default it will remain anomaly. We are also going to name our anomaly column as anomaly. So let us quickly do that. Fig equal to px, since we will be using plotly. So px dot scatter data frame equal to data frame, and x equal to x call, y equal to y call, and then color will be based upon the anomaly column. So fig dot update layout, and title will be, let's give it anomaly detection for, I'll convert this to f string, and here the variable will be for company, that will be Apple in our case, anomaly detection for Apple using method. So for isolation forest it will say anomaly detection for Apple using isolation forest method. So lastly fig dot show, so the graph is displayed. So this helper function is also done. Now moving ahead, so let us begin our first machine learning algorithm for this particular scenario. So let us copy the data frame with Twitter mentions for isolation forest. So let me name it isolation forest df equal to raw df and the name of the company. So we'll have a data frame of only the values for Apple. So we are only focusing on this particular column Apple. So if underscore df, so that is the data frame for isolation forest underscore dm. Now form the machine learning model, which is isolation forest, and here we are going to give contamination as 0.2. so we are going to assume out of 100% that there is going to be 20% contamination, that is the anomaly. This contamination score you can change depending upon the data set that you have. So based upon the use case you can change this contamination score, and then we will fit our data. if dot fit this data frame if underscore df, and then let us now predict the anomaly. I'll write it as pred, so we will get a series whether it is plus or -1. So for isolation forest, -1 is the anomaly, and if it is 1 then it is a normal observation. So if dot predict, and here we are again going to pass in this if underscore df. So for the existing data set we will come to know which are the anomalies and which are the normal readings. So this is the predict, and now let us replace -1 with anomaly and 1 with normal. So pred equal to normal if value equal to 1, else anomaly. So if value is not 1 then it will be classified as anomaly for value in pred. So this is just the list comprehension which I am using for this pred. So this is how we will be making use of normal if value is 1, else anomaly. So if value is not 1, that is if the value is -1, then it will be classified as anomaly. And now let us add the date time, that is this timestamp column, and this predicted column to this dataset if underscore df. So if underscore df timestamp equal to raw df timestamp, and then if underscore df anomaly equal to this pred. And now that this is done, let us plot the graph. So we will make use of this make graph function that we defined over here. So method equal to isolation forest, and then data frame equal to if underscore df. X column we will be taking timestamp, and then y column will be this company, the name of this column is company, and then anomaly column is anomaly. And let us execute this. So upon execution we have got this graph. So based upon isolation forest, anomaly detection for Apple using isolation forest, blue dots are the normal observations, and these red dots are the anomaly ones. So for example, here on 15th April 2015 Apple was mentioned 3857 times. So this it has classified as anomaly. So this is for isolation forest. Now moving on to oneclasssvm. So if you have understood isolation forest, what we have done in this particular code block, then the same thing we are going to do here for oneclasssvm. So it will be easier for you to follow. So let us create oneclassdf ocdf equal to raw company, since we are only going to be focusing on this particular column. One more thing which I forgot to mention, ideally this should be a copy of your raw data frame, because sometimes it may happen that the changes that you are doing on a data frame, if you have not made a copy of the parent data frame, it can cause changes to the parent data frame if you are not making the copy. So to be on the safer side, make sure you always make a copy of the parent data frame, and the child data frame should not be part of that particular data frame. Make sure it is a copy and not just part of that particular data frame. Now let us create a model. oneclasssvm equal to oneclasssvm, and here, similar to the contamination in isolation forest, you have to pass in the parameter of new. So here new I'll pass it as 0.2. so similar to isolation forest 20%, new I am going to pass in as 20%. so 20% is 0.2, and then I'll fit to this model oc underscore df, and now let us predict the anomaly. ocsvm dot predict, and here again we will pass in ocdf. It is not necessary that you pass the same data frame, you can pass in the incoming parameters. So since I have not made any test train split, so I am using the existing, so I am detecting the anomaly in the existing data. However, based upon this data frame, we have trained this model, so the incoming new parameters we can classify whether it is anomaly or not based upon the oc underscore df data frame that we have used to build this particular model. So we have got the prediction. So similar to isolation forest, it also classifies the normal and anomaly as 1 and -1 respectively. So if it is 1, then that means that particular observation is normal. If it is -1, then that particular observation is anomaly. So we have predicted this spread, and let us now replace this with anomaly and normal. So spread equal to, again, list comprehension normal if value equal to 1, else anomaly for value in spread. Okay, now this is done. Let us add this to this OC_DF data frame timestamp, because on x-axis we are going to plot time. So raw_df timestamp, and similarly OC_df anomaly equal to this spread. And now let us plot the graph. Method equal to oneclasssvm, data frame equal to OC_df, x column is timestamp, y column is our company, variable, because company variable is nothing but a variable holding apple, this string. And then anomaly column equal to anomaly, this particular column. And now let us plot this. So anomaly detection for apple using oneclasssvm. So this is how it is appearing. Red dots are the anomalies and blue dots are the normal ones. So for example, for this particular red dot or orange dot, however you interpret it. So for timestamp 21 April 2015 at 20 hours, apple was mentioned 16,534 times. So it has classified it as anomaly. Now lastly, kernel density curve. So let us quickly create our data frame. So KDDF kernel density, so raw df company, and then let's make a copy of it. Let us form the model. KD equal to kernel density, and then let us fit KDDF, and let us check for sample scores. You cannot directly predict using this model. You have to check for sample scores, select a threshold, and then if the value is less than the threshold, then it is an anomaly. So let us quickly check the scores. Equal to KD dot sample scores, score samples, and then threshold equal to, here we are going to make use of quantile. This quantile we have imported from NumPy. From NumPy import quantile, and the quantile we are going to keep for this particular example is at 20%, similar to the new and contamination that we used earlier. We are going to keep this quantile score at 20%. 20% is 0.2, and this we are going to apply for scores. So whatever scores we have for our existing data, so we are going to keep the quantile at 0.2. Now this is our threshold. So if our value is less than this particular threshold, that is the scores, if scores is less than the threshold, then it will be classified as anomaly. So I'll say anomaly. I'll add to this existing data frame KD_DF anomaly equal to anomaly if score is less than threshold else normal for score in scores. So this particular list scores that we will be recording in this particular column anomaly, and we will also add timestamp column as well, because on x-axis we are plotting time. kd_df timestamp equal to raw timestamp. Now this is done. Let us plot the graph. Make graph method equal to kernel density, data frame equal to kd_df, x column is timestamp, y column is name of the company, and then anomaly column is anomaly. And now let us plot it. Score sample missing. Oh right, I forgot to add this samples. I forgot to pass in our data frame, because it won't be able to tell the scores if we do not pass the data frame. Value of x is not the same in data frame. Okay, I made a typographical error over here. time timestamp. And now we have this graph, anomaly detection for apple using kernel density. So blue ones are normal and red ones are anomaly. So for anomaly detection for apple using kernel density, for this point if we see, on 3rd March 2015 at 21 hours, apple was mentioned 15.124,000 times. So it has classified it as anomaly. For blue dots, existing value, so 359, then 997. So these are the normal values, and there are also some values in the lower end, like for this particular point which is appearing, this orange dot 138. So it has classified it as anomaly towards the lower end. So this was the anomaly detection using kernel density. So just to quickly recap, in this particular notebook we saw machine learning based anomaly detection for univariate values. So we saw isolation forest, oneclasssvm, and kernel density. There is also a notebook where we have done anomaly detection using statistical methods. That notebook, and I have also created a video for that particular notebook. It is in the playlist. Also, you have this notebook on GitHub, the link for which will be mentioned in the description. You will be finding 2 notebooks over there. One will be unsolved for practice, so you can just open that notebook. It will have the instructions on how to execute the notebook. So if you want to practice and develop your skills, I suggest you take a look at that notebook, so you will be able to read the instructions and execute the code. So I would suggest you, if you have understood this particular video, go to GitHub and open the unsolved practice notebook. Try it on your own. If you face any difficulty, then refer the solved version of this notebook. So I will be keeping both the notebooks, solved and unsolved. So if you get stuck anywhere, you can definitely refer the solved notebook and get the answer. And that's all for this video. This was Shaunak helping you out with machine learning. And if you have any suggestions or have any comments, mention it in the comments. If you want to collaborate or work on any project, my email is mentioned here at the bottom, shaunak.python@gmail.com. So you can get back to me on my email. That's all for this particular video. I'll see you in the next video. Thanks.